Hello everybody. This presentation is for my Year 12 students. What I'm aiming to do is to run through exercise 2a and to see if we can just get some work up there and get started on chapter 2 and get through it in about 2 weeks of term. So in chapter 2 there are quite a few problems solving linear equations, and this is one of the types down here that I thought we'd have a look at. So x plus 1 over x plus 3 equals 3/4. What I'd like to do is to find out what value x could be. Now to do this, what I need to do is get the x's off the bottom, and so I can get them all into one long linear expression with no denominators there. So what I think I'll do is I'll cross multiply here, and I'll take that 4 and put it up there, and that x plus 3 and put it up there. So what if I go, let's see, well, 4 times x plus 1. And what about if I take that x plus 3 and put it up there? What I've really done there, I suppose, is I've multiplied both sides by x plus 3. Now if I do that, that cancels with that. But 3 times x plus 3, well, that's what I have here. Now if I multiply both sides by 4, well, the 4's cancel down there and get rid of the 4 on the bottom, but 4 times x plus 1, well, that's effectively what I have there. Okay, now what I can do is expand 4x plus 1, when I expand it, will be 4x plus 4, and 3 times x plus 3 is 3x plus 9. Okay, now what I'll do is I'll take away an x from both sides, 3x from both sides. Now that'll cancel down on that side and leave me with just 9. And 4x, take away 3x, is x plus 4. Now what I'll do is I'll take away 4 from both sides, and that will leave me with x equals 9, because 9 take away 4 is 5. Alrighty, let's try another one. Okay, here's another example of the type of equation. It's probably pretty appropriate to Year 12. So what we have is two fractions, two algebraic fractions, added together to be equal to 3. And what could be the value of x? Well, what I'm going to do is to find a common denominator. So I'll times by 5 to the top and bottom of this first fraction, and by 4 to the bottom of this fraction and to the top of this fraction. That way I get a common denominator. So if I said this will be 5x plus 1 over 20 plus 4x minus 2 over 20. All of a sudden now I've got a common denominator, so I can add these two together. So that'll be 5x plus 1 plus 4x minus 2. Now if I multiply by 20 for each of these, what I'll do is I'll get 5x plus 1 plus 4x minus 2 equals 60. I'll expand these brackets here, so that'll be 5x plus 5 plus 4x minus 8. Now let's see, 5x plus 4x is 9x minus 3. Okay, so 9x is equal to 63, so x is equal to 7. Alright, so whenever you get, I guess, a pair of fractions, what you've got to try to do is to find a common denominator and add the fractions together. Okay, well here we have a pair of simultaneous equations. Now really all we're doing with this is aiming for a bit of a review. So what I think I'll do here is I'll eliminate x. Okay, so if I multiply this top one by 2 and this bottom one by 3, I'll end up with 2 times 3 is 6x in the top line, and 3 times 2 is 6x in the bottom line. Then I can take these two away from one another. So that'll be 6x plus 2y plus 16. 2 times 3 is 6, 2 times y is 2y, and 2 times 8 is 16. Now in the bottom line, and I'm going to take these away, 3 times 2 is 6x, 3 times minus 4y is minus 12y, and 3 times 10 is 30. Now if we take them away, 6x take away 6x is 0, 2y take away negative 2y, well take away negative is a positive, so 2y plus 12y is 14y, and 16 take away 16 take away 30 is minus 14. So we end up with 14y is equal to minus 14. And if we divide it by 14 on both sides, we get y is equal to minus 1. Now if y is equal to minus 1, we could substitute that back into either equation. I might take the first one here and say, alright, if I know that, then 3x minus 1 is equal to 8, so 3x is equal to 9, so x is equal to 3. So I might be able to say, therefore, x is equal to 3, and y is equal to minus 1. Now, in this chapter, simultaneous equations come up quite often, and there is quite a complicated kind of an understanding that must be developed, especially later on in the exercises. Now the last one I wanted to do, I picked out a written kind of application question that's a linear application question from exercise 2a, it's question 7 on page 65 of the text. Now it talks about a water tanker or something where the water tanker initially has 10,000 litres of water in it, and somebody's hosing or something like that, and they're watering, or water is coming out at 10 litres per minute. Now the first thing they ask us to do is to write an expression for the volume of water remaining in the tank after a certain amount of time. So we could say, well, the volume of water is equal to 10,000 minus 10 litres for every minute that we've been watering. Now I guess you could do that intuitively or make up a table of values. So if you made up a table of values, you could say, well, how much water is there at the start? 10,000 litres. After 1 minute, how much water has gone out? Well, there'd be 9,990 litres. Then after 2 minutes, 9,980 litres. Then after 3 minutes, 9,970 litres. So, our equation relating the volume of water left in the tank after a certain amount of time would be 10,000 minus 10 litres per minute that the water is coming out. Now in B it says how much water is left after 1 hour. Well, after 1 hour, that would mean that would be 60 minutes. So the volume would be 10,000 minus 10 times 60, which would be 10,000 minus 600, so that would mean 9,400 litres would still be left in the tank. Now the third part says, well, how long before the tank is empty? That would mean that V would be equal to 0. So if I put in place of V 0, so that would be 0 is equal to 10,000 minus 10 times T, which would be 10T is equal to 10,000. So I can divide by 10 on both sides. By 10 divide 10, which would mean the time is 1,000. Now 1,000 minutes, if I divide by 60, is 17 hours and 40 minutes. I hope. Alrighty. Well, that just about covers most of the questions or the types of questions in 7a. If you have a problem, please ask me in class and I'll see you then.